Hello, my dear children. Today we are going to discuss about the solutions to the problems in exercise 3.4. Okay, my dear children. But you should learn well about the definition of elementary transformations. Okay, my dear children. Row operations are there and column operations are there. What are the operations? Total 6 elementary operations are there. Okay, my dear children. And what is meant by inverse of a matrix? What is meant by invertible matrix? Okay, my dear children. And we have to learn well about the properties of inverse of a matrix. Okay, my dear children. Right. Now let us start exercise 3.4 sums. See the first question. Using elementary transformations, find the inverse of matrix 1 minus 1 2 3. This is a given matrix. We have to find the inverse of this matrix. Let us consider the given matrix is A 1 minus 1 2 3. Remember these steps, my dear children. This is a very important model for the examination point of view, for board examination. Okay, my dear children. This is the first step. We know that A is equal to I into A. In this method, we write this first step for any question. We write the first here. To use the row operations, we use this equation. A is equal to I into A. This implies in this equation substitute A, matrix A 1 minus 1 2 3 is equal to I means matrix 1 0 0 1 identity matrix. We write here identity matrix into A. Understood this step, my dear children? Right. Here the main thing is in LHS there is a matrix. We have to make this matrix as an identity matrix by using suitable row operations. What is the matrix in LHS 1 minus 1 2 3? We have to make this matrix as an identity matrix. What is meant by identity matrix? 1 0 0 1, like this. We have to make this matrix, LHS matrix, by using a suitable row operations. So first of all, we concentrate, we focus on making the elements 0. See, in this diagonal 0 0 is there. So first we have to make these two elements as 0 elements. In the place of 2 and in the place of minus 1, we have to make them as 0 by suitable row operations. So first we take this 2. This number 2 is in the second row. You have to use the previous knowledge while you are solving two linear equations in x and y, a pair of linear equations in x and y. You eliminate x terms, y terms. Okay, my dear children. So we use the same. Consider in your mind, this is x term, this is y term, this is x term, and this is y term. We are trying to eliminate this x term in the second equation. So to eliminate this second equation, okay, my children, to eliminate the second equation, we use the first equation. Here R2, this is in the R2. So R2 implies R2 minus 2R1. By using this row operation, we get here 0. Remember this step, my dear children. Understood this step, my dear children. Then we get, this implies, see here R2, just I am writing here rough work. What is the first term after arrow symbol R2. So here LHS, I wrote here RHS. To understand this step well, I wrote this rough work. In LHS, I write matrix elements, two elements. Okay, my children. In RHS also, I will write two elements. See here R2, first term is R2. Means we have to write R2 elements in LHS. What are the elements in RHS? In the second row, R2, 2, 3. I wrote here 2, 3. Understood this step, my children? Similarly, in RHS, means in this row matrix, in the second row, what are the elements? 0, 1. I wrote here 0, 1. Understood this step, my children? Right. Now, what is the second term? 2R1. 2R1. In the next line, I wrote here 2R1. What is meant by 2R1? We have to multiply R1 by 2. What are the elements in R1? 1 minus 1. In LHS, 1 minus 1 are there. In RHS, 1, 0 are there. So we multiply all these four elements by 2. So 2 into 1, we get here 2. 2 into minus 1, we get here minus 2. 2 into 0, we get here 0. And 2 into 1, we get 2. So, okay, my dear children, 2 into 1, 2. 2 into minus 1, minus 2. 2 into 1, 2. And 2 into 0, 0. Understood this step, my dear children? Right. Now, what is the sign between these two terms? Minus. So, we are subtracting this second line from the first line. Then you get 2 minus 2, 0. 3 minus of minus 2, get 5. 0 minus 2, you get minus 2. 1 minus 0, 1. Understood this step, my dear children? Right. Remember this part. We use this rough work for remaining row operations also. Like this only we do the remaining operations also. Then we got this matrix. I wrote first row as it is 1 minus 1 is equal to 1 0. We wrote the first row elements as it is. Here first row elements are not changing, only second row. Whatever the letter written before arrow symbol, only that row is changing. Remember that point. Understood? Now in the R2, in R2 actually 2, 3, 0, 1 are there. Here we got 0, 5 in LHS. So I wrote here 0, 5 and here minus 2, 1. We wrote here these four elements in the second row into A. This letter A as it is. We write this letter A as it is. Understood this step, my dear children? Right. This implies now we have made this number as 0. Now we are trying to make this number as 0. Previously I told you this is a y term and this is also y term. The first equation, this is y term and this is also y term, the second equation. So we are making these in the first row. We have to make this number 0 because I told you here and 0 and here also 0. So to make this number 0 by using this number, how can you get here 0? R1 implies here R1 is changing. Remember this one, 5R1 and here plus R2, 5R1 plus R2. Just we interchange these two numbers to R1 and R2 here. First write R1 and R2. Just to write these two. This is in R2. So write before R1 and write this. Here is 1. Consider here 1 is only, not minus 1. Write this number before R1. If they are same of a sign, then we put here minus sign. If they are opposite, their opposite sign, we keep here plus a sign. This is very important rules. Understood, my children? Now we find the elements in the first row. Second row elements as is 0, 5 minus 2, 1. See here 0, 5 minus 2, 1. In the next step, second row elements as it is. But first row elements are changing by using this row operation. What is first term? 5R1. See here, I wrote here 5R1. So we have to multiply each and every element, all these 4 elements by 5. So I multiplied 5 into 1, 5. 5 into minus 1, minus 5. 5 into 1, 5. 5 into 0, 0. Understood all these 4 elements? Here in the first row, 4 elements are there in LHS and RHS. We multiplied all these 4 elements by 5. I wrote here as a first line. In the second line, R2. Next term is R2. What are the elements in R2? 0, 5, minus 2, 1. I wrote the 4 elements as line 2, second line. In between these two terms, plus sign is there. So, plus. So, we are adding these two lines. So, 5 plus 0, 5. Minus 5 plus 5, 0. 5 minus 2, 3. 0 plus 1, 1. So, all these 4 elements should be written in the first row because only first row is changing. So, in the first row, we write 5, 0, 2, 3, 1. I write all these 4 elements in the first row. We wrote R2 elements as it is 0, 5, minus 2, 1 into A. We write this letter A as it is. Understood, my dear children? Right. After getting the zeros in the required places, okay, my dear children, now we have to identify in the first row what is a non-zero element in LHS. In the first row, there is a non-zero element in the first row in LHS, that is 5. So we divide the entire row elements by 5 to make it as 1. Okay, my children. Similarly, in the second row, we have to find out what is their non-zero element in LHS. In LHS also, in row, second row, there is 5. So we divide the entire elements in all LHS and RHS in row 2 elements by 5. Then we get here 1 0 is equal to 3 by 5, 1 by 5. If we divide second row elements by 5, we get here 0 1 minus 2 by 5, 1 by 5 into A. Understood this step, my dear children? Right. So here in LHS we got an identity matrix. Understood, my dear children? Right. So we say that this matrix is a inverse of the matrix A. Therefore A inverse is equal to 3 by 5, 1 by 5, first 1 minus 2 by 5, 1 by 5. This is the inverse of the given matrix. Understood, my dear children? Right. Now come to the question number 2. Using elementary transformations, find the inverse of the matrix 2 1 1 1. Okay, my dear children. So first of all, we assume the given matrix is A. So A is equal to matrix 2 1 1 1. Told you already. First of all, we have to assume that given matrix is A because the given matrix is not denoted by any letter. So we assume that A is equal to 2 1 1 1. After that, we write this step. I told you clearly. Using the elementary row operations, we use this step. We know that A is equal to IA. This implies in this LHS we write matrix A is equal to, in RHS I we write identity matrix 1 0 0 1. This is an identity matrix of order 2 into A. Understood this step, my dear children? Right.